Kada motor is actually pretty fast. Hey Marco. Right. I mean, we need to see how we could solve, how we can solve this here. So basically, shifting. What do you mean, what car? Don't you people ever read the description of the stream? I mean, everything is in the description. It's a Countach. Yeah. But I still haven't figured out how to do this. I mean, the gearbox as is works nicely, but how to motorize it? I mean, there's some effort, you know. If you are shifting up here, it's fine, but the moment you start shifting at the level of the pin here, shifting is a bit more difficult because the lever, of course, is smaller. Obviously, we cannot go up to have a bigger lever. But what to do? That's the question. I don't know. I have no idea what to do. We tried clutches, which theoretically work, but not really in a practical sense. I mean, people have posted in Discord a few solutions that I don't know if they are really viable like that. I mean, we could theoretically put a motor input in here and have a lever with a slider here that then could allow for manual shifting and then shifting with the servo. The problem is that if we do that, of course we compromise all of the structure here because there's obviously not enough room here. Not that it's illegal. Thing is, there's just no room. I've been thinking about your design, but you know, we have to remove all of this structure here if we want to incorporate it, and there's just no room for it. No room. And we cannot put the servo directly onto the lever. Because obviously the servo is way too strong, and you know this needs to spring back, but with the servo attached it just won't, of course. No. Okay. My man, this is hard. Yeah, that's impossible. So I mean, once we make this, it's gonna be very satisfying, but and you know we are going to come up with the mechanism eventually, and it's gonna be satisfying, but god damn it, what is it gonna be now? I mean, the mechanism that we had before So where, you know, the lever, where's the old lever? I still have it. Yeah, where the lever here was coming up to there, you know, this thing. I don't know. I don't know if this is a good approach or not. Not sure. There's no room for on the underside because there's a chassis. So you cannot, there's just no room. Whatever we have to do, we have to do here on top. And this lever has disadvantages, of course, because we are shifting from a high vantage point. So we are shifting from up here. And when we are shifting from up here, first of all, we are pushing it in this direction where it goes, so forward where it goes. Okay, I cannot show you because I have just so many fingers and you know. So when we are pushing this forward, it's okay, but the problem is when we are pulling it backwards. And of course the angle here. No, we don't need the slider here. Or we do basically, yeah. We do, because as we discovered, the clutch here, this clutch here, in theory it's interesting, but it's doesn't allow the servo to turn fully 90 degrees, which is bad for the servo, and we don't want this. And one other problem here with the lever up here, of course, is that once this is angled, see, this thing here is not gonna be centered, so it's always gonna be, whatever we do here, it's gonna be at a slight angle. And of course, if we're looking from the 3D perspective, look at how much inwards we need to go diagonally to get to the lever. There must be a way. I'm sure of that. There must be a way, but I just don't see it. Just don't see it. I mean, we have a good idea how to do the pop-up headlights with the remote. So we're gonna use these here. But this, initially I thought I had the right idea, but it's gonna turn out to be a nightmare. And I really like this gearbox. I mean, we have really done a good job with it. This is really nice. Practically no excess material. Everything is really nicely designed. Yeah. I mean, one thing that obviously we're gonna try at the moment is, I'm really curious about the speed. So we obviously changed the gear ratio. In the last stream, this thing ran empty, so we couldn't test it. But now let's put this into the car and see how fast this actually goes with the one Kada motor only. But before we do this, we need to fix this, because this is constantly creeping out, even though we have it like supported. And we cannot have this. So we need to come up with a way for this not to creep out. Ideally, it would be, I don't know, something like this, and then something pushing against it. I don't know. Let's build it in and see. Hey, scrap mechanic. Of course. Yeah. There. So we are only going to connect the Kada motor, not the Lego one. Okay. Oh, come on. Okay. Yeah, that's exactly what we probably have to do. I don't know. Yeah, I mean, the name is gonna be something different, obviously. What do you think? Obviously, you're gonna name it like something, the Red Devil, or I don't know. What gear are we in anyway? Okay. And that's only with one Kada motor. If we use the Lego one, we would be slower, so that's fine. And this is starting in fourth gear. I mean, it's still not fast, you know. It sounds faster than it is because the rollers are smaller, but it's still not gonna be very quick when you drive it around. Damn it! I mean, I would like it to be a bit faster, but obviously it's not meant to be. I mean, the red Italian supercar is probably just as quick as this. Probably not much faster. No. The problem is shifting from third to second, where the shifting arms are basically shifting out of each other, and then at one point both gears are engaged, and that's where the car stalls. That's the problem. That's the only reliability problem. Upshifting, no problem. Downshifting, problem. But I think downshifting is only the problem on the rollers. Shouldn't be a problem when the car is driving, because the momentum is gonna just get past the point. So down into third, no problem. Tripping out again. Third, no problem. Now from third to second. Now it goes. It probably depends on where it is. Now it's first and up again. Yeah. Yeah. This guy, as you can see, it's creeping out. So it has crept out by, you know, like almost half a stud already, and it's gonna do it even further. The problem is if we put a lift arm on the back here, it's gonna wear out. So we need to find an actual engineering solution for this creeping out, not just a band-aid. No, I mean obviously it's happening because everything here is shaking, and you know it's basically being this thing is basically being walked out a little bit by everything here. So maybe if we manage to, you know, like find a solution where we can use this as well, so that, you know, this isn't gonna just, you know, shake, or basically this cannot happen. No. Okay. So, I mean, what we're gonna do is, of course, we're gonna find a solution for this, and we are going to see what we can do about the mechanism for the pop-up headlights. Obviously, today we are going to use the motor we have. I don't have the small motor that we are probably gonna use in the end, but it's about the mechanism, you know. So the small motor is gonna work in the same manner. It's just gonna be smaller. So yeah, let's take this out again. First, half shifts. Come on. Hey JSP. Well, what we have right now, it's not very sexy looking. It's almost disassembled. But you see how easy. Nice. You see how easy it is actually to insert the gearbox into the car. If anybody remembers at the beginning when the gearbox was in the way of everything, now it's just, you know, you put it in like it's nothing and take it out as well. So we did something right. So yeah, this is a problem, of course, that we need to fix. Yeah, modularity, you know, that's my fetish. So what are we going to do? Yeah, it is. It is. As modular as you can make it. Obviously, that's the strongest non-friction pin I have ever seen. Wow. Right. Exactly. That's how I approach it. If the real car can be modular, so can this. I mean, unibody construction it's perfectly all right. I mean, it's hard to provide a better rigidity and safety for your occupants than with a unibody. So, unibody is what we have. It is what it is. Well, the bigger L bracket, I don't know. Problem is, it's in the way of everything, more or less. And the good part about this here is that it has an axle hole. Yeah. This is not giving us any I wouldn't want Lego to be out of metal. Not at all. It would be way too heavy. You couldn't do anything that we can do here. You would need, it would be dirty because you would need loop. So I'm pretty happy that Lego is made out of plastic, and it's, you know, it's the challenge of trying to make things out of plastic. That's interesting. So obviously we have to redesign the whole concept of this here. Obviously this is fine, but it's not gonna be what we're gonna use in the end because it just doesn't work. Obviously we're gonna have the switch here, but the bracket for it's gonna be redesigned. So, you know, we can use this here and it's not gonna creep out on us. And you know, it's just, it creeps out because it can move. You know, if we make sure that it cannot move, it's not gonna creep out. Obviously this has to be flat because underneath is the enter roll bar, so we cannot change this. Enter roll bar, we'll see if we could. Let's see. I had some ideas for changing the enter roll bar, but I don't know. Ideally, these would be axle holes. You mean these ones? These ones are from Lego. They are only 15 and 11, yeah. But Kada obviously has all the lengths, so. Yeah. Kada has a lot more of them. Problem is, these are in a very inconvenient size. And we don't have a lot of mounting options here. So let me think just a little bit. Because here, obviously, we would have the only option here would be like this. With this, we could, you know, then continue. If this was an axle hole, we could use this here, put it on. We can't. And we need this here because this obviously is holding in. It's holding in the whole part here. So it's kind of tricky. We cannot use lift arms here to extend because then they hit the gear, of course. It's gonna be, well, you know, not that fast. If you want fast, you need the buggy motors. It's okay-ish. I mean, you know, you've seen how quickly the wheels rotate, and that's it. You know, the problem is that the motors are just not fast enough. If we would use buggy motors, they are much more powerful, so we can use different gearing, and they are you know, only thing that we could use here, I think. Yeah, we cannot use this here. Ideally, we would, you know, use this gear here instead of that, and then this, but this just doesn't mesh, sadly. Yeah, buggy motors with proper gearing. These two just don't mesh. That's the problem. And that's what we can have here. In here, we are just limited by the size of it all, and we have used this here. I had, you know, I had this differential before, but people have said that this differential, the Kada's differential, is pretty crappy. Yeah, I mean, I'm not in 4 gears is enough. 4 gears is plenty enough for any model. So, you know, all of the Lego. This is annoying me. All of the Lego cars that have so many gears, I don't really understand this. I mean, you have so many gears. Basically, your whole car is the gearbox, and it's still shit. Just focus. And I mean, you sacrifice the construction of the whole car to have a multi-speed gearbox, and then your gearbox is shit, your car is shit, it's slow. Yeah, I mean, here with the Countach, this is actually how the actual gearbox looks like. If you Google like Lamborghini Countach drivetrain, this is how it looks, basically. minus the two motors behind, but you know, that's a concession to what we're doing here. But it is like this. It looks exactly like this. So this part is like in the real car. The motor is exactly here. Uh, it's very accurate, and you can remove it in one piece and change it and whatever. And we are not sacrificing the design of the whole car for the gearbox. And look how slim it actually is. With Lego, you would have the entire floor of the car like a gearbox. Well, there's no Lego automatic gearboxes. I have not seen a Lego automatic gearbox that actually properly works. So I don't know what you're talking about. Um, yeah. So let me think. If we would replace this part here with something that connects to this, or even if we replace this here, but then we would need to replace it with something that we can mount here in a way. That's the problem. This is the ideal part for this. The ideal part. Anything else? Anything else would not fit here. Well, there's no parts for making automatic gearboxes. I have no idea how to make. I have absolutely no idea how to make an automatic gearbox because there's no planetary gears. I mean, we are with planetary gears we are extremely limited. Obviously, we're not going to use a differential for planetary gears because the differential is useless. It's not strong enough. And anything else, you know, is not viable. So automatic gearboxes are not really an option. Yeah, I mean, that's probably the best bet we can do. And then we are gonna use this here. Or maybe not. Damn it. I thought we would clear it. It's sad, yeah. It's sad. The state of MOX is sad. Is sad. I know. I mean, the at least the non-technic mocks are great. I mean, I see a lot of cars that are like creator, you know, creator level. Those mocks I really enjoy, even though they're not technic, but I really enjoy them. And even with Lego, when they do when they do like speed champions and the creator stuff. Um, you know, I like this, even though I know they're not supposed to be like accurate with suspension and stuff. What they have is fine. It's about the looks, of course. Mexican muscle cars with adjustable suspension. What? Uh, I've never heard of it. What are Mexican cars with adjustable suspensions? Um, I don't like this bit. It's kind of inefficient. Maybe we can do something like this. Um, yeah, maybe we can do the whole back here modular. Yeah, maybe we can do the whole thing here modular. Exactly, exactly. So it's gonna be much better. Yeah. Okay. Okay. Nice. Nice. Oh, lowriders. Right. Okay. Then say lowriders. I know what lowriders are. Okay. So it goes like. Yeah. Okay. Yeah. Here we have the stop is here. Okay. Okay. Well, lowriders are American, as far as I know. Mm. Ah, okay. Yeah. So we cannot use these. We have to use this here. That is not true. You do have lowriders in Finland. They're not. They're just not in. Not in everyday traffic. Bungas 2D. Um, you will have to speak English because we don't understand whatever the language you are speaking is. Sorry. Um, that's just how it is. Okay. Okay, now we need to connect this here, this here, somehow, and of course this has to be in here. And we could use this here, this. That could possibly work. and then the same way we already had this here. Yeah, that's probably what's gonna happen. Yeah. So we'll use this here. That. And here, since we need two axles sticking out. Well, obviously I'm gonna use this here. Probably gonna be fine. No, we don't need to use this. Of course, we can use just one side. We are going to use this as the limiter. Yeah. I mean, I find it really strange on anywhere in the internet, in various discussions where you have, people of various languages come together, and then you have a group of people that always speak just their language, which is something nobody else understands. I don't understand this mindset, that you assume that people just understand what you're saying if it's not English. I don't get it. I would like to understand it. So if anybody who's doing this would come forward and explain it to me, why this is happening, I would really like to understand it. Okay, so right, very satisfying click. And I guess there's only one way to see if this is gonna creep out. We need to put it in the car again, run it again. Yeah, having knowledge about other languages is perfectly fine. And the more languages you know, the better. But you cannot just assume that everybody speaks your language. What? Oh, stupid me. Stupid me. Of course, I have turned this the wrong way. Yeah, whatever. And especially, nowadays, where everybody, you know, nobody has an excuse to not know English. It's not gonna be terribly fast, I'm afraid. Not in stock form, because that's what we are, working with. So that's first gear. Second gear, third gear, fourth gear. Now downshifting. Yeah. So, Tim, you need to do a recalculation because we changed gears. So, you know, it's not particularly fast. Even for the scale, I would like to it to be faster, but for this, we would need to use different motors, which we don't have, because Kara doesn't have the buggy motors. I would absolutely use buggy motors if I could, but they don't, as to my knowledge. If they do, correct me. I'm gonna order two immediately, and it's gonna be a lot faster. But as far as I know, they don't. So we have to use what they have, and these are the same motors that are being used um, in the red supercar. So, but in case you haven't noticed, it has not walked out. It's not no longer creeping out. So we have fixed it. I know Buick sells buggy motors, but we are doing a car for Kada, and Kada does not have buggy motors, so that's what it is. There's no neutral gear. Why would we need neutral gear? I don't understand. Neutral gear is not necessary. Since it's an electrical vehicle, if you want neutral, you just don't drive the motors. That's it. If you want reverse, run the motors in reverse. That's why it doesn't have reverse gear. Yeah, and then what? Then you put it in gear and break all the gears. So yeah. So we have basically a 28 gear driving at 20, and then the axle on which the 20 is has another 20. So basically 28 to 20, 20 to 60. That's the gearing up. Then whatever happens in the gearbox, those are the gear ratios. These have nothing to do with the actual gearing of the motors. And then we have, of course, the 12 tooth to the 28 tooth of the differential. This has been done so that the speed in the gearbox is higher, but it's transmitting, well, the torque going through the gearbox itself is lower because of this. So if we had the 20 gear driving the differential, a lot more torque would go into the gearbox or through the gearbox. This is a more natural way of doing things. The cars that you see on the road, they all have a differential ratio of something like this. So, you know, in order to reduce stress upstream of the drivetrain, you always have a fast spinning drivetrain with a roughly 3-to-1 ratio. It's never 3-to-1, but it's, you know, it's sometimes it's 4-to-1 or whatever, but it's, you know, it's always in this ballpark. It's never like 1-to-1 in the differential or close to 1-to-1. Maybe in dragsters, but even then, there I don't think. Yeah, the motors, GSP, the motors will work as a brake, but that's the problem. The moment you put the car into gear, the motors will act as a brake, and the gearbox is gonna brake. You're bound to break a gear when you're going fast and you put it in gear. You know, 355. You know, Biggie. Every car has a different ratio. I know BMWs, for example, the E30 itself has the gear ratio, the differential ratios vary from 2.48 to 4.4. So, you know, you have a large variation even there. So, but it's always, you know, 3-to-1 is a good ballpark. This isn't 3-to-1 because it's 12 to 28, so it's like more like 3 point something to 1. But, you know, it's 3-to-1. If you design a differential and you say it's 3-to-1, it's a good ballpark, you know. Yeah. Okay. Enough of this. Let's see if we can come up with a solution to open the pop-up headlights with the motor. No, we're gonna revisit this anyway because we need to do this, but not today. I mean, so we need to motorize the pop-up headlights. Obviously, we're gonna use some levers, and we're gonna use, since we want them to be both openable manually and with the motor, and the motor is not gonna be a servo, so we need to use one of these slipping clutches. The Mustang and Challenger wheels were just basically simple remote control car wheels. So, you know, wherever you can buy remote control car parts, there you go. So where do we put this and how do we approach this? So the travel on this is just one stud, which is good. which is good. We have to use these, which is going to determine actually the size of our system here. And since this clutch has the output here, we need to drive this with the motor. So with a small gear, this is going to be driven with a small gear, and the motor, and this is going to then slip, and yeah, very, very simple mechanism. We're going to try it here. So let's see if we can use this here. The motor that we are gonna use right now, because I don't have anything else, is gonna be this, but in the final version it's gonna be the small motor. So I guess this is one place where we can actually use the 8-tooth gear. The only place where an 8-tooth gear actually makes sense. Obviously, I don't have a single 3-stud axle, but it has to be. It's gonna have to be a 4-stud one. Just a second. How do we do this? Yeah, not like this. It's just testing, so okay. So that's the axle onto which our lever is going to be connected to. Okay. So a lever is gonna be this guy, I guess. No. Brake bit. Yeah. I mean, you can do a lot of things. This is Lego, so you know, everything's possible. Question is, if you really want to. Okay, so basic idea is that this here, so this here, is gonna be connected to this, like so, but with a connecting rod, I guess. Yeah, with a connecting rod. Obviously, it's not gonna sit here. This is just, you know, me experimenting. Ideally, we would have it here somewhere. Yeah, let's do the connecting rod part first. Let's do the connecting rod part first. I mean, This is, oh, we don't need a connecting rod because this is moving enough. Okay. Yeah, okay. Hold on, hold on, hold on, hold on. Hold on. What do you mean, where does the motor come from? It's... I think Lego has the same kind of motor. It's a Kala motor, so... Okay. We're gonna stick it in here somewhere. Don't know how yet. Okay, this is retracted and then need to, yeah, okay. 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 I have a basic idea. How to do this. So we need to modify this here. So this guy here is not gonna move back. It's gonna move forward, and we can use this here to mount this part to the car for testing, of course. You know, I just want to see if this is strong enough and everything else. So we're not gonna, you know, go like wildly overboard here with stuff. No. Okay. Now we have this here. We need pins here. So we need 2 attachment points here. No, we didn't solve the shifter problem yet. We did not. So we need this here, and we need another one here, but we cannot mount it here because of the gear. We need to improvise something here. Yeah, probably. Yeah, we'll do this. I think we can mount this now and try. Okay. Does it correctly? Yeah. Okay, so let's see. Can we open it with manually? Yes, we can. We can. But this needs okay, this needs some more it needs to be mounted more in a better way. I mean, no problem opening it manually. Let's see what the motor says. Ah. It's gonna be a disaster. What? Obviously, it's not supposed to move like that, but damn it. It works. Okay. Proof of concept. It works. This is going to be a smaller motor. We need to hide this somewhere here. But the basic idea works. Okay. Very good. Very good. And we can theoretically, because we have the clutch here, theoretically we can, yep, we can open it manually. So we can use both the motor and the manual labor to pop them out. It's gonna be even better, you know, once we fix this in place, because now this can move, and that's, you know, not okay. But the motor has to be different. We need to mount the motor is going to be smaller. It's going to be the micro motor, and we are going to turn this around so that the motor is going to be under the dashboard here, and then it's going to be covered by the dashboard, so it's not going to be seen. That's the plan. Yeah, and it's going to mount onto this here, onto the beam that goes here. Yeah, very good. We have electric headlights. Nice. They don't open up enough. This is another problem. Because I don't know, something, but it's basically in the fine tuning of the motor here. Yeah, can I see? No, it's fine. Yeah. Okay, let me just hold the motor in place so it doesn't go around. Okay. Yeah. Yeah, it's fine. That's the full range of motion. Yeah, that's fine. There's room for, if we use the micro motor, it's there's room for it, and behind the dashboard. And since we're gonna redesign how it's connected to everything, it's gonna be plenty of room. Yeah, yeah. I'm pretty happy with this. So Kala has buggy motors. Okay, interesting. I wasn't aware of this till now. Um, I have no buggy motors here, so I cannot even, try. But if they do, oh my, does this open up possibilities? Oh my. This is gonna make the car so much faster, which would be awesome. Which motor? You mean the servo? No, there's no space for it. I don't think so. Hmm. Nice. Nice. Is this a newer model from them? I need this. Oh god, yeah. Yeah, we need the motors because this car deserves to be faster. Absolutely. No. No. By the way, yeah, JSP is not here anymore. He forgot to post the links to the stuff we were talking last time here. So for buying the servo motors individually, I mean the motors individually. Um, yeah, and those buggy motors. Yeah, we do need them. We do need them. They will make this like double the speed it does now, probably. Yeah. Anyway, I don't think we are gonna accomplish much more today. So, yeah, we do need to make the something here with the gearbox, obviously. Should have space behind front bumper. Okay. Okay. Then, yeah, then we can put the micro motor there. And if the micro motor is not strong, not very strong, which would be actually good, then we could use the motor directly. So no gears, nothing, and if you want to open it manually, you just open it, because the motor is on the axis of the mechanism. Since the motor is not strong, there's not much resistance, you can open it like that. Yeah, that's a very good idea. That would be great. Yeah. This is how we're gonna do it. Yeah. Independent, independent of everything. Even if we change these motors to the buggy motors, we still do need to make the shifting mechanism. That's independent of it. And then of course we need to finish the rest of the car. Seems to come from generator. Okay, so this is something new, right? Okay. Yeah, I do need those buggy motors. Yeah, definitely. Definitely we're gonna use buggy motors here. Yeah, it's decided then. Yeah, so please bombard me with links. We're just nah, they won't. Maybe with downshifting. Maybe they won't stall. They will just rip through it. Well, then maybe we should, or they are, but that's not fundamentally a problem. That's not a fundamental problem. We can, I guess, accommodate them somehow. I mean, the main problem with this is that this is slow. That's the main problem with this. This is slow. The buggy motors, we could place them like here in this section here, like across, and they would be like as wide as the gearbox, so there shouldn't be that much of a problem. I don't see that much of a problem. They can be just behind the bumper. No, I don't remember. As I said, spam the pictures into the Discord, and we'll take a look and have a debate about it. Because right now, I don't know. German I can deal with. Korean I cannot, but you can always switch on subtitles. So, I guess that's an option. Yeah. Anyway, that's it for today. I'm going for a walk, and let's talk about this over the weekend on Discord, and see what we can come up with. And then we can discuss this on Monday live on stream. So yeah, thanks for watching, and I see you on Monday.